Testing, one of the most discussed topics probably in the community besides clean code. However, something that is missing in these discussions very often is performance tests. We will have a look in this video at two tools that you can use in your project in order to inspect, profile, and improve your source code. Before we can start, however, we have to make sure that we have the necessary plugins installed. What we need is Xdebug for our PHP. Once we have installed Xdebug, what we have to do is we have to make some changes to our PHP ini file. Just paste these few lines of configuration text into your PHP ini file and you're good to go. Make the changes according to your own needs. Once we have done that, we're already good to go. Now, when we open our web application, what this is doing is it creates two log files for our application. One is called Cachegrind and the other one is called trace. We can use these two log files and import them in our tools in order to inspect where we have hotspots in our application that are called very often or that are very, very slow. We can also check out the memory usage for some of our functions. The first tool I would like to check out is called Cachegrind. I'm currently on Windows, so I'm using Cachegrind. Once I'm in the application, I can import my Cachegrind and it will generate a view that looks similar to this. On the left side, we have a performance view where we can see the time spent in the different functions. And on the right side, we can look at the callee map, for example, where we can see the different functions, where they are getting called and how long it takes for them to run. We can sort this list by the total time used, or we can sort it by only the self time that is used in these functions, which means it only includes the code that is inside that function directly, not the time that is used for subsequent functions that this function maybe is calling. When we click on this, we can see the slowest or longest running functions in our application. This means these are our hotspots where we can probably gain the most time if we make any improvements. We can also see which files these functions are located in, and we can see how often these functions are called. Sometimes it makes sense to sort by the time inside the functions themselves. Sometimes it makes sense to sort by the amount of times a function gets called. We can also see all the callers that are calling this function. So sometimes you have a loop where you're calling a certain function, and by pulling that function out of the loop, you can save a lot of time. We can also check out the source code if we are having the source code on the same machine as this tool, which I don't have in my case. What is a little bit confusing here is that the time is spent in 10 nanoseconds. So all the time here is not nanoseconds, it's in 10 nanoseconds. I don't know why they're doing this. To me, it's a little bit confusing. So this number up here is not 11 milliseconds, it's 111 milliseconds. That is just something that you have to keep in mind. So what I like to do is I look at the call tree, right? I sort by time self, and then I go through the top functions and check out which functions are using most of the time in my application, because these are the functions where I can gain the most if I optimize them. In my case, this is a data mapper function which is creating objects from the data that it is pulling out of the database. So if I would optimize this, I could save a lot of time, in this case up to 160 or 111 milliseconds if I could optimize this function. If I want to visualize which functions are calling this function, I can also go down here, click on call graph, and I can see all the other functions that are calling my function that I'm currently inspecting. This is very nice because it is much easier to visualize and it's much easier to understand where these functions are getting called from and how the application workflow works. Another tool that you can use for your performance analysis is a flame graph. In my case, I'm using Xdebug Trace Visualizer. There are many different tools out there that you can use. It's a very, very simple tool in this particular case, because you can just download it and it's working on your own machine as long as you have a patch, for example, installed. Or alternatively, you can go online. There is a page available where you can just drag and drop your trace files, and it will generate this flame graph, which is very, very helpful in order to also identify heavy functions or functions that have a lot of subcalls. So what you can see in this chart here is you can see the entire application time. Down here, this is the lowest bar, and then you can see with every stack above, you can see one function call. So what you would like to do if you have such a chart is you of course want to make it shorter in length, right? So in this case, the application execution is almost 500 milliseconds. So you want to make it shorter, like 300 milliseconds or ideally sub 100 milliseconds. And another thing that you want to look out for is how tall these towers are in our flame chart. Where you're reducing the depth of these towers or the depth of our function calls, we make our application easier in terms of workflow, in terms of application flow, and also easier to understand for a software developer. So these are the two things that I'm looking out for when I'm looking at this flame chart. How much time is spent, of course, in total, and how tall are my towers. I also like to render the internal PHP functions so I see how often I'm calling any of the internal or default PHP functions. These are usually the very small lines that you can see in this chart here. The larger ones are usually my own functions that I've defined in my source code. When I click on these sections here, it shows me the file and it also shows me the function that is getting executed and run. So by clicking on this, I can identify which functions are taking a long time. So the longer the bar is, of course, the more time it takes, but it doesn't necessarily mean that the function itself is the slow part. It can also be that the function calls that this function is executing and running are the actual slow part. As you can see here, execute get is making many subcalls to other functions, and ideally I would like to reduce the amount of subcalls it is making in order to avoid all of this execution time. Of course, this is also very helpful to identify parts of your code that you maybe want to use for caching. So in this case, I have one function call here in the beginning, which is called load account, where a user account is loaded when he visits our website or our web application. This means if I look at this one, I know that I can optimize it simply by caching the data that is happening in here. Or if we look at this part, we have a create default page view. This is also something that I could put into caching, and I would save, in this case, 70 milliseconds of runtime. So these two tools are, at least for me, very helpful to identify slow code or complex code and help me to improve my application in general. I hope these two tools also can help you. Of course, there are many more out there. I chose these two tools because they are very simple to use, very simple to set up, and honestly, very simple to understand at least. Thank you for watching and see you soon.